Hi and welcome back to part 2 of our Kerberos deep dive series. My name is Alex and in this part we are going to talk about Kerberoasting. If you have missed the introduction to Kerberos, you can go back to part 1 where we cover the basic functioning principle of Kerberos. Before we dive into the actual topic, a quick note on the use of Wireshark in this video series. Throughout this session, we will be using Wireshark to inspect Kerberos traffic. Now, as we have learned before, Kerberos traffic is at least partially encrypted, and that makes it more difficult to analyze it, specifically all the minute details. And for that purpose, we have configured Wireshark with the key material of the whole domain, so of all user accounts within our domain. So we will be able to look at each and every part of the Kerberos messages. Now, whenever we will be looking at Wireshark and you see a segment with a blue background as depicted below in these images, in this image here, this part would normally be encrypted and you will not be able to see the actual contents of it. If you want to find out more about this, you can look at part 1 of this video series for more details. However, let's quickly do a quick refresher on the basic mechanisms that will be relevant for Kerberoasting. If you remember, the high-level authentication flow of Kerberos looks as follows. We have a client that wants to authenticate to a specific service. So for example, a file share running on foo.local. And for that purpose, the user first logs in on the client and then requests a ticket granting ticket from the authentication server part of the KDC. If that all goes well, we receive this ticket granting ticket, and with that ticket we can then go to the ticket granting server or service of the KDC and request the specific service ticket to access foo.local or the file share on foo.local. So we request the service ticket for the specific SPN in question. We pass along our ticket granting ticket, and if everything is validated correctly, we will get back a service ticket. With said service ticket, we can then present that to the target file server, and if we are effectively authorized to access the service, we will be able to establish the connection. Now remember that this part of the Kerberos flow, where we request a service ticket for a specific target service, we can do that no matter whether we have the correct permissions or not to access this service. So that is not evaluated by the ticket granting server or the KDC. It will simply issue a service ticket back to us, and then with this service ticket we will go to the service and the service decides whether we are allowed to access or not. So this part we can do for any service that is available within our domain. And now for Kerberoasting, we essentially will focus on only that specific part of the Kerberos authentication flow, requesting service tickets. On to what Kerberoasting actually is. So what we want to achieve with Kerberoasting is we want to extract data, some kind of data, we'll see what exactly later, that is encrypted with the account credentials of a service account, and then try to crack that offline to retrieve the password of the service account in question. Now what we exploit here specifically is typically password hygiene or bad password hygiene, and ideally weak encryption. The encryption itself, we have different algorithms available in Kerberos, as you might know already. It has definitely impact on the efficiency of our cracking attempt. It doesn't make it impossible, but it makes it much harder depending on which algorithms are used. In Kerberoasting attack itself, we as an attacker only interact with the KDC, so the domain controller, and not with the target services specifically. So we only just request the service ticket, but we don't connect to the target service. Let's quickly do a refresher on the specific details when we request a service ticket and then eventually get it back, so the TGS rep part of the request. If we look at that into detail, we can see that when we get the ticket back from the ticket granting server, we, among other things, get this service ticket. And the service ticket itself, the main important factor here for Kerberoasting is that this ticket is encrypted with the secret key or the Kerberos key material of whatever the target service is. So if we target a file share running on FS1 associated with the machine account on FS1, that will be encrypted with the key material derived from that account's password. If we access a SQL instance running on DB1, which is associated with the user SVC SQL, then this ticket will be encrypted with the key material derived from the account password of SVC SQL. We can also look at that in Rubeus, not in Rubeus, in Wireshark. We're going to be using Rubeus for that. First of all, to request a ticket, to be able to request a service ticket, we need to get a ticket granting ticket first. So we're going to specify our account along with a credential to Rubeus, so we get back a usable TGT. Now with this TGT, as you're familiar, we can use that to then in turn request a service ticket with the ask TGS command, and we'll specify the service that we would like to access now, namely HTTP running on ws1.child.testlab.local, and we pass along the ticket granting ticket that we received before. Now what we see here in the output is the service ticket that we have requested, and if we look at Wireshark, we can follow along those steps. So in the request itself, for the service ticket, we have all the options that we're already familiar with. We can see that we send along the pre-authentication data, which is the encrypted timestamp. We specify what kind of service we would like to access, so the HTTP service, and then in the response, we actually get back the actual ticket itself for the HTTP service. And if we check, because remember we enabled the decryption in Kerberos, or in Wireshark specifically, we can see that this part is encrypted, and we can also look now how it is encrypted, namely using the key material associated with the SVC IAS account in our case. So essentially a key derived from the password from that account. Now, how exactly does Kerberoasting work, and why does it work? If we look again on how service tickets are created, it goes like this. So we as a user request a service ticket. This ticket is encrypted as we've just seen, and the encryption key used to encrypt this ticket is the Kerberos key from the target account that is associated with this service. So as we've seen before, that could be the SVC IAS account, for example. And the key itself, the Kerberos key material, as we already learned in the first part of the series, is derived from the account's password. So now to crack this, we essentially reverse the process. We take a password candidate, whatever we would like to try to guess, let's say password 1. From that, we derive the Kerberos key material. Remember, these are predefined functions that we can look up, so there's no secret in there. Well, this is all well defined. And then with the key material, we can attempt to decrypt the service ticket that we requested, just as we've seen before. And then we just look at the outcome. If the ticket decryption is successful and we get the correct data structure back from the decryption process, we know that we've put in the right password, and essentially we have found the password associated with this services account. If the decryption fails, so we get the gibberish, non-readable output, we know that we have not chosen the correct password, so we can take a new password candidate and then just repeat that as long as we would like to, ideally until we found the correct password. Now, there are some requirements and constraints to this attack. What we need to perform is actually a valid domain account. It doesn't have to be a high privileged account, but we have to be able to communicate in an authenticated way with the domain controller. So that could be where we have actually code execution on a user's machine, or we know the user's password. Then, of course, we also need line of sight to the KDC to request the tickets, and the target account that we would like to Kerberoast must have a service principal name configured. Remember that in Kerberos, to actually authenticate towards a service, this service needs to have an SPN set. You can enumerate all the SPNs in a domain via the Active Directory, via LDAP. We've seen that as well before. So it's not hard to find the accounts that have an SPN configured. And as we've mentioned before as well, remember that we as an attacker don't need permission to access that specific target service that we are going to be attacking. Any user in the domain is able to request a service ticket for any available service. The eventual outcome of the connection, whether we are allowed to access the service or not, is not relevant for the Kerberoasting attack. One more thing to keep in mind, and most of the tools that perform Kerberoasting will always already take that into consideration, is that targeting machine accounts, so services that are operated by or associated with a machine account, doesn't make much sense to attack them. The reason for that is that in a Windows Active Directory environment, the passwords of machine accounts are randomly generated and very, very long, so 120 characters by default, and they are automatically updated every 30 days. So even if you get a service ticket encrypted with a machine account, you can basically never crack that because the password is way too strong. Now, how do we actually perform Kerberoasting? There are multiple tools available for this, both on Linux and Windows. The most famous ones are from Impacket to get user SPNs. We can do the same thing with Netexec, Impacket, and Rubeus as well. And then most of these tools will automatically gather the SPNs that are viable for Kerberoasting. Remember, no machine account, the Kerberos TGT account as well is excluded because its password is generated randomly. And for some other tools, you can also specify which users you want to Kerberoast specifically. After we have done the Kerberoasting, so we have collected the encrypted data that we want to use, we then have to crack it. And again, there are some famous tools out there that fully support this. Could be either John the Ripper or Hashcat. Now, let's first look at how we can do Kerberoasting from a Kali machine. In the first example here, we are going to use the Impacket get user SPNs command, which will automatically retrieve all the SPNs from the domain and then dump the encrypted material. We have, of course, to provide the DC IP because this machine is not domain joined, and then a valid user account so the tickets can actually be requested. After we have provided the password, the tool will then check the Active Directory, query all the configured SPNs and require the ones that are viable for cracking. In our case, those are 2 instances for HTTP on WS1 and MS SQL also on WS1 as well. Then let's quickly look at the output of this command. We can see that we have 2 lines in our output file for the respective services that we have roasted with the Impacket tool. As a second method of performing Kerberoasting, we can also use Netexec. Here again, we specify similar parameters, so where the LDAP connection should be made to, that's the IP of the DC. We specify our user along with the password, and then the actual attack that we want to perform, so the Kerberoasting. And it needs, again, some more information on where the KDC itself resides, which is the same DC as well. And then we can see that we essentially get the same output. It will enumerate all the viable accounts, find two records, and it will also provide us with some additional details about the accounts in question, so we can even see what group memberships those accounts have. So we might already know which accounts are more interesting to crack. The output itself for those two accounts are essentially the same as we've seen before with the Impacket tool. Next, we're going to be looking at Rubeus if we are on a Windows environment. Now here specifically we are on a domain joined machine in the context of a domain user, so we don't need to worry about authentication specifically. So we can instruct Rubeus to perform this Kerberoasting attack and simply specify the out file where we want to collect the hashes. And then we can see in the output that Rubeus does essentially the same thing as the other tools. It will query the Active Directory for viable accounts that have a service principal set, user accounts, not the KRB TGT account, and some other restrictions that are checked. Again, we end up with two accounts, SVCIS and SVC-SQL. And then if we look at the output, it's essentially the same thing again. So we have for both accounts, we have the encrypted material that we can then attempt to crack. Now, I should quickly give you an idea on what we've actually collected or how this is structured. Essentially, it's mostly the same for all of the tools. If we look at the output, we first have an indication of what kind of ticket or message it is that we have collected here. So KRB5 TGS tells us it's the result of a TGS request, so a service ticket that we have collected. Then the encryption type itself, if you look at the mapping online, you can see that 23 maps to RC4. And then we have the associated account. So in our case, it's the SVCIS account in the child test lab local domain. And all the rest is then the encrypted ticket that we will eventually attempt to crack. For cracking itself, we have multiple options. Mentioned John and Hashcat. In the first example, we are going to be using John. We can see that we have all the outputs from our different tools, get user SPNs, Netexec, and Rubeus, along with a word list. In this case, I'm going to be using RockU. Now, of course, for cracking, you have to make your own considerations on what kind of word list and mangling rules and so on you want to use. But for our case, this will be enough. Now, first, let's use John. We simply pass along the word list that we want to use, so RockU in our case, and then provide one of the files that we have collected. We can see that after a short while, John was already successful and found one of the passwords for the two hashes, and then it will run out eventually when it has tested the whole list. So the second account was not crackable because indeed it has a strong password configured. But now the peculiar thing is that if you look at the output, it doesn't really tell you which account this password belongs to. This is a bit of an oddity in John. And even if you follow along the tutorials that tell you to use the show command with the file you provided, you still get no usable output. There's one last thing you can do here. You can look at the actual file where the results are stored. This is in your home directory, usually in the .john.pot file. And in here, you will eventually find that this password A1, B2, C3, and D4 belongs to the SVCIS account. Now let's do the same thing using Hashcat. Or actually before that, one thing I want to show you that I've stumbled across. We've seen that John has loaded two hashes in our case. If we do the same thing and use the output from Rubeus, you will see something that doesn't work correctly. It only loads one hash, which is the one that has already been cracked, and for some reason the second hash has not been loaded. Now the reason for this is that if we look at the actual content of the Rubeus output, you will eventually stumble across that there is a difference between the first and the second line or notation, how it is specified, and what makes John not properly recognize the account is the colon for the port that is present in this SPN. So this messes with the interpretation of John when it parses the file. If we simply remove the port and then run the command again, you can see that John is now properly able to load both of the password hashes. So just keep that in mind in the future if some of the hashes will not be loaded for you. Now let's jump to Hashcat. So we can do the same cracking attempt as well. For Hashcat, we have to specify the correct algorithm that is going to be used. You can look that up online, and then simply again specify the file that we want to crack along with the word list as input. So again, ROCU. And to no one's surprise, Hashcat will also be able, of course, to crack this, and it will also at first glance tell us which account this password that it found belongs to. Now on the encryption algorithms that are used, and specifically on the impact on cracking, just a quick overview on that. As we've already learned previously, in Kerberos you can use multiple encryption algorithms. Initially there was DES, and nowadays we have RC4, AES-128, and AES-256. And which of these algorithms is used for every specific case when you request a ticket depends on different things, like the domain function level, the configuration of the account itself, the account type, so whether it is a user or a machine, and so on. And the actual impact the encryption algorithm has is how the Kerberos key material is derived from the user's password. So there's a string to key function defined in each of the encryption standards, and this string to key function is used to take the account's password and derive the key material from it. So for example, if we look at RC4, the string to key function is simply MD4, which is the same thing as how Windows stores passwords, so the anti-hash. And if we go to AES, we use the PBKDF2 function with a default of 4096 iterations. So it's much more computationally intensive to derive the key material in case AES is used compared to RC4. To quickly visualize this, I have some results from a benchmark where I have compared the cracking speed of all three algorithms, so of RC4, AES-128, and AES-256. And if we look at the first output, so how efficiently Hashcat is able to brute force MD4, we arrive at this number. If we do the same thing for AES-128, we see that the difference between those two, or the factor, is roughly 500, and so that means 500 times slower. And if we jump to AES-256, it's even a lower number. It's roughly a factor of 1,000 times, or 1,000 times more effort that is required to crack the hash. Now, the interesting thing is to know what kind of encryption types are actually supported for the various accounts in your domain. And the list of supported encryption types is specified in an attribute on the account, namely the MSDS supported encryption time attribute. And this corresponds with those checkboxes you can set on the account itself within your Active Directory environment. One thing to know is that for computer accounts, these settings are by default set to RC4, AES-128, and AES-256. So all computer accounts in your Active Directory environment by default support all those three algorithms. If we look at a user account, this attribute will not be set. So if you query them, you will not get anything back. And there the default applies, which is RC4 to ensure compatibility. By the way, DES is not supported anymore since Windows 7 and 10, Windows Server 2008 R2, and later on. Now for actually checking the encryption type supported, we can do that with PowerShell. I'm logged in on the domain controller right now, where I have the Active Directory PowerShell module installed, but you can run that from any other system that has the same module available. If we first check a computer, let's take client 1 in our example and query for this specific property, the MSDS supported encryption type. We will see that for our client 1 account, this attribute is set to the value of 28. And this you can then look up into in the Microsoft documentation, and you will see that 28 corresponds to indeed RC4, AES-128, and AES-256. As we've learned before, this is the default setting for a computer type object. If we compare that to a user, let's take tmasi in our case, and again query the same MSDS supported encryption types property, we will now see that this attribute is not present at all. As we've learned, this is not configured for users by default, and if it is not configured, it will fall back to the default, which is RC4 in our case. And now just as a quick example, what we can do is for our user account, we can now go into the Active Directory Users and Computers tool and actually configure the supported encryption type algorithms. Let's, as an example now, enable AES-128 and AES-256. And we just rerun the same query again. And now we see that the attribute is now present and set to 24. If we look that up, it indeed matches to what we expect, AES-128 and 256. Now let's see how this plays out, or the supported encryption algorithm play out when we actually request tickets. I'm going to be using Rubeus in our case, and I've set up Wireshark with the Kerberos filter to capture all the relevant traffic. First, so we can actually request service tickets, we have to request a ticket granting ticket again with the ask TGT command. We specify our user and password, and we get a usable ticket granting ticket that we can pass on to the next commands. What we are going to do now is that we request a service ticket, specifically for the service CIFS running on fs1.child.testlab.local, and we pass along our TGT, and as a result we get back a service ticket for the CIFS on fs1. Now that we can already see in the output of Rubeus, we have some encryption types that we offer in our request, and we also see some information about the key type that has been returned, although don't get confused by this. This does not refer to the encryption of the service ticket, but rather of the session key that is passed along as well. We can inspect that into more details in Wireshark. So if we go to the TGS request, we can see that indeed when we request a ticket, we offer all kind of, as we say, we support all encryption types available, so RC4 and AES in both variations. And in the response, we get the ticket itself, so this is the service ticket, and we get the encrypted session key. Now for the service ticket, this, as we've learned before, is encrypted using the key material of the associated account, so the service account. In our case, this is the FS1 machine account that is used to encrypt this ticket, and the encryption type is AES 256, which is the highest one available for machine accounts. If we now request a service ticket for a service that is associated with a user account, so in our case http ws1 child.testlab.local, we can see a difference in the behavior or in the response. So we again get a service ticket. We offer all, or we support all encryption algorithms. And in the output, it still tells us that the key is encrypted, or the key type is AES-256. But again, this is the session key and not the service ticket itself. And this will be more clear if we look at Wireshark again. So in the request, we can still see we as a client, we offer all, or we support all encryption algorithms. And in the response, if we look at the ticket, we can now see that the ticket is in this case encrypted with RC4. And the reason for that is that if we look at the associated key material or the account, it's the SVC IIS account, which key material have been used to encrypt this ticket. And SVC IIS is a user account, not a machine account. And that explains why we use RC4 in this case, because it's a default. Now, in previous versions of Windows, namely Windows Server 2016 lower, so-called downgrading attacks were possible on the encryption types available or supported in Kerberos. What you could do as a client, you could specify that you only support RC4 as an encryption algorithm, and the KDC would then honor that and return a ticket that was indeed encrypted with RC4 in all cases, so ignoring all the configurations that you apply to your algorithm. However, this has since been fixed. And one more thing to keep in mind from the attacker's perspective is that this technique to specifically request RC4 tickets also has a negative impact on operational security. So it makes you easier to be detected. And we have some more information on that on the next slide. So OpSec consideration wise, we have already learned that tickets encrypted with RC4 are preferred for cracking, as it is much more efficient. But to specifically request RC4 encryption on tickets, so performing this downgrading attack, is quite easily detectable because it's an outlier or an anomaly. Normally our modern Windows clients will not do that. They will offer or support all kinds of encryption algorithms. So if you have a few requests that specifically asked for RC4, this is very easy to spot. And for that purpose, some of the tools that we have used for performing Kerberoasting have support for operational security to address this specific issue. For one example, if we look at how Rubeus does this, you can specify the RC4 OpSec flag, and this will have the following impact: that Rubeus will first query all SPNs in the domain and check the supported encryption types for the accounts, and it will filter out, or it will look at all accounts that do not specify any encryption type, so where the attribute is either empty or set to 0, and as we've learned before, this then defaults to RC4 as an encryption. And subsequently, Rubeus will only request ticket for those accounts. Now, Rubeus will still specify that it supports RC4, AES-128, and 256, knowing very well that it will only get RC4 tickets back because the target account only supports RC4. And with this technique, you will be able to blend in much more into the regular Kerberos traffic in the domain. We can quickly have a look at that in a real-world example. So again, I'm going to be using Rubeus to perform a Kerberoasting attack. And in the first case, we simply run it with any other additional arguments, and we see that we get back 2 Kerberoastable users. Rubeus will simply query the domain for any account that has a service principal name set, is not the KBTGT account, and has not some specific features disabled. So as a result, we get back the SVC IIS account with which is encrypted in RC4 because it's a user account that is associated with it, and we get the SVC SQL account, which is in our case now AES encrypted. It's still a user account, but we have specifically for this case now configured those encryption algorithms to be supported. Now we can clear that and run the Kerberos attack again, but this time specify the RC4 OpSec parameter. And as a result, we see that we only get one Kerberosable users back, because Rubeus will actively query now for users that have RC4 enabled but not AES. So in this case, it will add an additional filter to the LDAP query regarding the supported encryption types, and this will then filter out all the accounts that have not RC4 enabled by default and no other algorithms. Finally, let's talk about the countermeasures that you might want to apply in your environment to address Kerberoasting. There are multiple things to consider, starting with the fact that service principal names should only be configured where they are strictly required. The reason for that is that to perform Kerberoasting, or you actually need an SPN configured on the target accounts. An account that doesn't have an SPN configured cannot be targeted by a Kerberoasting attack. So it's a good idea to regularly clean up your environment and remove SPNs that are no longer required. Second, you definitely want to restrict the privileges of your service accounts according to the least privilege required. So for example, it's not a good idea to have a service account that is domain admin or has domain admin equivalent rights, since if this account is compromised, for example, through a Kerberoasting attack, the attacker would gain full control over your environment. Then, along with that, you can also think about restricting the logon options for those accounts. Typically, service accounts don't need interactive logon rights on your machines, so you might want to remove those privileges. This does not render the account fully unusable to an attacker, but it makes their life much harder. Then, since the main issue behind Kerberoasting is usually bad password hygiene, you would definitely want to apply stricter password policies to your service accounts. So while for regular users, you might say that 10 or 12 characters is long enough for a password, for your service accounts, you might want to increase this to 20 or even 30 characters. In addition to that, you should also ensure that passwords are always exclusively randomly generated for your service accounts. To even improve the situation further, you can also switch to so-called group managed service accounts, or GMSA, that where the main benefit lies in the automatic password management through the Active Directory. So the password of these accounts don't have to be defined, or they can't be defined by regular users anymore, but rather the Active Directory will automatically create and rotate these passwords for you, making brute force attacks on the password essentially impossible. We also have learned that the encryption algorithms have a major impact on the feasibility of cracking attempts, so it is a good idea to also configure restrictions there. Specifically, you should never use DES or RC4 encryptions for your accounts. Just keep in mind that you might run into some compatibility issue with legacy systems on that, so carefully check before disabling those. On the contrary, you should then only support AES 128 and 256. Lastly, there's also monitoring to be considered. So you notice when a Kerberos attack is going on in your environment. For that, you first need to enable the audit Kerberos service ticket operations on all your domain controllers, since the attacker might communicate with different domain controllers during their attack. So you have to ensure that the auditing is enabled on all of them. And once enabled, you can then specifically look for excessive ticket requests. So everything that is out of the ordinary amount of ticket requests that you observe on a daily basis. Specifically, that will be the event ID 4769. And typically in combination with RC4, since this is much more interesting for attackers to facilitate easier cracking. This concludes part 2 of our Kerberos deep dive series. If you've got any questions or remarks, please feel free to leave a comment and we'll get back to you. Thanks for watching.